Thank you for being here, sticking it to the end. Although I have to say this is not the end. Brian is doing a demo after me, okay? Don't miss it. So this was supposed to be a status talk. Status talks are boring. So I'm going to go quickly through the status, the actual facts, and then I'm going to share a bit more with you. So hopefully it will help you understand that status, where we are and our plans. So I just want to mention our current team. No real particular order, except the first line is our old-timers, and the second line are brand new people. They've been with us for something like 9 months. So they are the Dragons team. I'm not Dragons. The whole team is Dragons. Okay, maybe I should just look there instead of there. So the status as of now, it hasn't changed much since last year, unfortunately. So for all spectroscopy, you still have to use Gemini RF. It's coming, it's really coming. And then for all imaging, do use Dragons, just forget about Gemini RF at this point, use Dragons. Sorry. We do have the quick look, GMOS long slit. And if you wonder what quick look is, it's basically to give you an idea of what your data looks like. So currently, the way I see it is that since you have to use Gemini RF to reduce your GMOS long slit, and it's quite time consuming, I agree, then you might want to do a little quick look reduction with Dragons, super fast, and it's going to tell you if it's actually worth your time to reduce the data properly. So what is in development now? Something I think I've alluded to last year is this nighttime processing, quick look processing of data for the target of opportunity observations. The software is in place, everything is ready. We're currently in the testing phase and monitoring to see how it behaves for whenever the Gemini North now, whenever there's a TO in our test environment, it triggers and reduces the TO, imaging and GMOS long slit. Then for the long time promised GMOS long slits for science, the software is in place. What we're missing right now is the documentation, and then there's a lengthy testing phases. And because of the GMOS South amplifier problem that happened in January, we had to last minute add a new feature to better handle that. So this has not been fully tested, and we know there's some issues that will need to be fixed. And what is happening right now, and we have staff, well, right now they're sleeping, but what the team is working on is the near-infrared long slit. And here, notice I said near-infrared, I didn't say just Genius or just F2. We're writing for both, making sure that the software is written in a generic enough way that most of it actually is reusable across near-infrared long slit instruments. Future, we're going to cover everything that Gemini RF covers now. So the near-infrared IFU NIFs, and now Genius. The Genius cross disperse the MOS, GMOS and F2, which is now being offered as FT. And GMOS IFU will also come. And keep in mind that all this is also valid for our new instruments. So Ghost, the data reduction package, is written for Dragons. It will be distributed as a third-party software until we find a time to fully integrate it into Dragons, but it is Dragons. Scorpio, so Scorpio will basically reuse almost all of Dragons that we have, because Scorpio is imaging, optical and infrared, and long slit spectroscopy, optical infrared. Well, at this point, we almost have everything. We're working on the last piece, the near infrared long slit. And GearMOS, we're already in talk with the GearMOS team. It's going to be an image slicer IFU in the near infrared. And we're in talks with iGrins, where currently the software, the pipeline is the iGrins pipeline in Python, but we're trying to work out a way to get it into Dragons. And we're probably going to meet this week. That's the plan. Sorry about that. So now let's go into a bit of understanding. What we're trying to do here is save a lot of effort and make things faster in the long run. So what we're doing is investing now on one pipeline infrastructure that actually works for several instruments. So if you think about that long term, we don't have 10 pipelines to support, we have one. It's just that there's a lot of code reuse, smaller code base, and it will help us because we're a small team. We cannot have 10 experts on each pipeline. So we need one pipeline, uniform model, and a lot of code reuse. That's the only way we can actually do it. Now, I think the UCGP people and staff people have seen the castle slide. So just to show you where we're going, what our strategy is, and where we are right now. Everything is on that slide. So I was told I can use, can you actually see it? Nope, I cannot see it. Oops, that's not what I wanted. I cannot use it. So I'm gonna try. Well, I hope you can see this tiny little bit. So what we're doing, what we've been doing is basically building a foundation. So we have the Dragons bit here, Astrodata, recipe system, continuous integration. Testing is extremely important. If you want us to release often and fast, we need to automate the testing because there's a lot of code and a lot of tests. We're using the community library, so AstroPy and the likes. We are reliant on the archive for the calibration association. That's very important. And then the way we did it, so well, we have 4 pillars. We have optical and near-infrared imaging, optical and near-infrared long-slit spectroscopy. And think about it, once you have those 4, and you've written them in a very generic way, you can build with more fancy nodes after that. So at this point in yellow, what you have is what we have completed. It's not fully released here, but the code is ready, and we're currently working on building this bit. And it looks somewhat bad. We say, oh, we just support imaging. Well, when you look at the demand, imaging is 1/3 of the usage. So it's a big chunk. And in a few months, when we release long-slit spectroscopy for science, Dragons will cover 2/3 of the data being taken. That also is very significant. And then we'll just keep going. So we're currently working on F2 and Genius long-slit. And then we'll move to NIFS and Genius IFU. And just probably that's the way we're going to do it. So it will depend on what happens because all plans have changed over the past. We try to adapt. Also, we need to adapt based on the resources that we have. And just to talk a bit about the future, as I mentioned, Scorpio will be reusing the imaging, the optical long slit, the near-infrared long slit. GearMOS, that's part of the reason why we're working on near-infrared IFU, is because we want to get GearMOS going and have a nice foundation when they start coding for the instrument, which is our next instrument. And of course, now we have Genius IFU, so it's yet another motivation to go on with this one. And after that, these pieces of the pie, I call them the multi-slit data. So with long slit, we have one slit spectroscopy. All the other ones are really a variation of that, is you just have multiple slits. So once we figured out a generic way to deal with multiple slits, then it will open up this section of the pie chart. And now just a few difficulties that we've had, because I'm sure you're all saying, why is it taking so long? Well, it's tough. So just a few examples that I have here. Finding reasonable aperture, we're trying to automate this. So if you're going to do spectroscopy, you're not necessarily going to have just one source. You might have multiple sources, and it would be awfully nice to be able to detect them all automatically and extract them all automatically. When you have a very nice flat and point sources, easy. When you have something like this, not so easy. So just last fall, and not last fall, last spring, we spent a lot of time. This Monica was involved, Chris was involved, Oliver was involved, everybody was involved into trying to find a good algorithm that would work reasonably well with things like that. And then we had a nice surprise with the, thank you, with the GMOS, GMOS South, the AMP fail. That was, we managed, actually I have to say that when I first tried Dragons on the data, without any changes to Dragons, I was really impressed by how well it worked. We still needed to do some work with it, but it was very, very promising. So, but it did cause several months delay, actually. Another problem that we often have, and that one was when I read the talk, it was very prominent in the work we were doing. Sometimes the WCS, the world coordinate system, are unreliable for some unknown reasons, which is usually not that big a problem. But when you're trying to automate a reduction, then it becomes a big problem. Conduct packaging, poor James Turner, once in a while he gets really a tough one with the conduct packaging, won't package, and it's a mess. A release could take an extra week just because of these things. And during COVID, we lost half our team. We lost 3 team members. So that was also a big hit. And we have got complex instrument, just take GMOS, tunable wavelength, multiple gratings, multiple binning. So you can imagine all the testing that needs to be done in order to make sure that the software works. And now just for lightweight stuff, Jen stole my slide here. I have it bigger now. So this is an example. This is an automated, fully automated reduction. You go from the raw data, the 2D stack with cosmic ray. So this is a science version and a very nice extracted spectrum there. So software exists, it works well. We just need to finish the polishing. And what's coming with the science quality version? A bunch of interactive tasks. So there's a screenshot of all the new tools that we'll have to help you really optimize and get the most of your long slit spectroscopy. Okay, so I cannot demo them, but catch me this week if you want to see them in action. I can run them on my laptop, and they're really, really cool and very intuitive to use. And that's the end of my talk. Thank you.